In this class, we will see several ways in which landline cables can be bugged, and in the part of countermeasures, we will see ways to detect and prevent this kind of espionage. So here we can see the 4-pay telephone cable where each pair is twisted, and all four are also twisted between themselves to reduce both the effect of the magnetic field called inductive as well as the electric field called capacitive, as we will see in the next slide. We can basically find two types of cables. UTP is unshielded twisted pair, and STP is shielded twisted pair. So here we can see a parallel splice where the clamp connects with the two strands of the twisted wire, but it is also possible to have other types of splices, as we can see in the next slide. It is necessary to say that this is possible on analog lines because when the device is digital, when the telephone device is digital, a coding process is applied in the phone-based circuit to the analog signal that comes from the hook of the telephone device itself. And listening demonstrated here can only make sense if you have the information that makes it possible to decode encrypted traffic according to the model and manufacturer of the telephone device. So I must say that a lot of the coding, let's say, models, or a lot of models of manufacturers the telephone are known in the market, and this can be done, but there are also other models that might not be possible to do when it is a digital phone. As I mentioned in a previous class, it's possible to capture at the base of the device the analog signal that comes from the hook and route it to one of the three pairs of the telephone cable, and in this way capture the analog signal of the call, even if the device is a digital device. So we can bypass this problem of encoding the traffic by a digital phone device. So here we can see four types of taps that can be made on the local line of the fixed telephone network. The wiretap is shown in the direct image, and in this case it is a radio transmitter, but it can be done in several other ways, including, for example, local recording by a recorder, or even transmitted via cell phone. The first tap shown is a serial tap, and it connects with one of the twisted pair wires and is activated by the line current when we lift the telephone handset hook. The parallel tap is the second, connects with two twisted pair wires and is activated by the voltage difference between the two wires when we lift the hook. The inductive tap takes advantage of the fact that an electric current passing through a conductor generates a magnetic field. Changes in the magnetic field under the right conditions can induce, and from here is the name inductive, can induce current flow in another nearby conductor. So the current induced in the second conductor will vary according to the original current, providing us with a duplicated signal, basically. Since the signal is magnetically induced, no direct connection to the original conductor is required, and in this sense, when we make a sweep on telephone lines, it is much more difficult to discover traces of wiretapping that were made in the past. Because with inductive and also with capacitive taps, we don't have to deal with the shielding take out the shielding of the wires in order to connect the tap. In both cases of parallel and serial clamps, we can see traces of the splice on the wires, so we can know that there have been some illegal activities in the past. The capacitive tap is similar to the inductive tap, but can be placed externally on top of the entire twisted pair, and it takes advantage of the electric field that exists between the wires of the twisted pair. As I said, while the inductive tap takes advantage of the magnetic field of the wire of the twisted pair. In the following image, we can see the difference between the use of magnetic field by the inductive tap and the use of electric field by the capacitive tap. So here we can see that when a current passes through a wire, it generates a magnetic field, but when we are dealing with twisted pair, where there is also a second wire where current passes in the opposite direction, and in this way the magnetic fields are in opposite direction and cancel each other, but there is a reduced magnetic field, and this field we capture with an inductive clamp, while the capacitive clamp captures the electric field that is created between the wires. By copying these fields, it can be possible to recreate the sound that generates those fields.